All right, let's dive right in. We are talking about one of the most incredible, most fascinating machines ever built by humankind, the nuclear submarine. It's this silent hunter that can just vanish beneath the waves, not for a few days, not for weeks, but for months at a time.
But how on earth is that even possible? I mean, really think about it. How does a crew of over 100 people live, breathe, and work inside a sealed metal tube completely cut off from the entire world? Well, it all comes down to solving three absolutely massive engineering challenges. And the first, and without a doubt the most important piece of this entire puzzle, is power. We're talking about a source of virtually limitless power generated right there, deep in the heart of the submarine.
You see, the old diesel-electric subs, they had this critical weakness. They were basically tethered to the surface. They had to constantly come up for air to run their diesel engines and recharge their batteries. And every single time they did that, they were totally exposed and vulnerable. But nuclear submarines, oh, they completely rewrote the rulebook.
So inside every nuclear sub is a compact nuclear reactor. It uses this process, nuclear fission, to generate a frankly unbelievable amount of heat. That heat boils water, which creates high-pressure steam. That steam then just blasts through turbines, spinning them like crazy. And those turbines, they do everything. They generate all the electricity for the entire ship, and they turn that massive propeller at the back. And here is the part that is just truly mind-boggling. The energy density of nuclear fuel is insane. A single fuel load can power a submarine for its entire operational life. We're talking over 30 years without ever needing to refuel. That right there is what makes it completely self-sufficient.
Okay, so with unlimited power pretty much sorted, the next challenge is just as critical for survival. How in the world do you create a breathable atmosphere when you're hundreds of feet deep in the ocean?
Yeah, it's a huge question, right? You can't exactly crack open a window. You've got over 100 people in this sealed environment, all of them constantly using up oxygen and exhaling toxic carbon dioxide. So what's the solution?
Well, they just make their own oxygen. They use a process called electrolysis. And remember all that endless electricity we talked about from the nuclear reactor? That's the key. They use it to run an electric current through seawater. It's this brilliant, self-contained system. The electrolysis splits the water molecules, the H2O, into hydrogen and oxygen. The oxygen, the stuff we need to live, gets pumped right back into the sub's atmosphere. The leftover hydrogen gets safely vented overboard. And at the exact same time, you have these chemical scrubbers that are constantly working, literally pulling the carbon dioxide the crew exhales right out of the air. It keeps the air totally fresh and breathable 24/7.
Now for our third piece of the puzzle, and this one might just be the most important of all. A nuclear submarine's greatest weapon isn't its torpedoes. It's the ability to simply not be there. It's the engineering of pure, absolute invisibility.
For a sub, silence is survival. The whole point is to move through the ocean without being detected by enemy sonar, which is always listening for the tiniest sound. So every single nut, bolt, and pipe is designed with one goal in mind: be a ghost in the water.
So how do you actually achieve that level of silence? Well, one of the most advanced ways comes from research into something called a split shell hull. The idea is pretty simple, but the engineering is pure genius. Just think of it like a super high-tech sandwich. You've got an inner steel hull and an outer steel hull, but the filling between them, that's where the magic happens.
That filling is a special viscoelastic material. So what does that mean? Well, when sound waves from inside the sub, the hum of machinery or the crew moving around, hit this layer, the material literally converts that sound energy into tiny amounts of heat. It essentially swallows the noise, damping the vibrations before they can ever escape into the water and give the sub away.
So, let's recap. We have a machine that can make its own power for decades, literally manufacture a breathable atmosphere out of seawater, and can wrap itself in a cloak of almost perfect silence. What else could there possibly be?
Just think about what we've covered. We've got a ship with unlimited power. It's got its own constantly recycled atmosphere. And, I didn't even mention, it's got an endless supply of fresh water that it distills from the sea. It really is a completely self-sufficient world sealed off from our own.
So, if the submarine can make its own power, and it can make its own air and its own water, what is the one single resource that it absolutely cannot produce on board? What's the one thing that forces this incredible machine to finally turn around and head for home?
The answer is almost comically simple: food.
A submarine is basically a giant, floating, high-tech pantry. They typically pack about 90 days' worth of food for the entire crew, and it's crammed into every available nook and cranny, storerooms, freezers, sometimes even stacked in the passageways.
And that's it. That's the limiting factor. After all that incredible, mind-bending physics and engineering, the nuclear reactors, the electrolysis, the acoustic damping, the final countdown for a multi-billion-dollar warship is determined by its groceries. The mission ends when the food runs out.
It really is a masterful combination of systems, isn't it? You have a nuclear reactor for endless power, an atmospheric generator for endless air and water, and then this incredibly sophisticated stealth engineering to stay a ghost in the deep. It's all working together to let humans conquer the abyss.
And that kind of leaves us with one last, really fascinating thought. We've seen how technology has conquered all the physical limitations of living deep in the ocean. But what about the human element? What are the psychological challenges of living with 100 other people in a steel tube with no sunlight and zero contact with the outside world for 3 months straight? That is maybe the most complex system of them all.